Here at Southwest Strings, we're proud to provide professional setup and adjustment on each and every instrument that comes through our doors. Our Luthier is staffed by our industry professionals that have the knowledge and expertise to make sure that your instrument plays at peak performance. If you're shopping online, you need to know that unfortunately many online dealers simply ship you an instrument straight from the factory. We want you to know that here at Southwest Strings, we invest time and attention into every instrument. Now here's Rebecca to demonstrate the setup process.
Hi, I'm Rebecca. I'd like to show you how we set up your instrument at Southwest Strings. We start here at the fingerboard table where we work on this piece of ebony. The fingerboard is kind of the most basic important part of the instrument upon which we build the rest of the setup. So it's really important that this fingerboard is properly adjusted. We have a high point on one end and a high point on the other, and then we have a little bit of a dip in between. It's very important that it's perfectly smooth so that when we have strings placed at the proper height, you get no buzzing. It makes it very easy to play at that point. So here we check the instruments to see how close we are, and to make adjustments we use the plane, we use a scraper, we also check the radius of the fingerboard as well. Now I'm going to show you how to set up the rest of the instrument. Okay, now that we have our fingerboard prepped, we're going to take a look at the pegs. We start out with a blank peg that's oversized, and it needs to be fitted to the peg box. We have a couple of tools to do that. First of all, we have the peg reamer, and then we also have the peg shaper. The taper for this reamer absolutely matches the taper of the shaper. So we put this into the peg box and just take as minimal amount of material off as possible. But we want to make sure that we have just rounded out the holes perfectly so that they're going to be a perfect taper matching this reamer. Then we take the peg shaper. It's kind of like a pencil sharpener. And we just remove material until the peg shaft is small enough to fit all the way through, and we match each peg that way. So each peg fits specifically to that particular peg hole. You can't really take all these pegs out and randomly put them back. Each one is specific to its particular space. So once we have those fitted, we use Hill peg compound, which is kind of a lubricant, and which is good for anybody to use if you're finding that your pegs are sticking tight. I do kind of a combination. I take a look at where the peg box is touching the pegs, usually a smooth area on each side. Give it a little bit of peg compound. I like to use just a little bit of rotten stone, which is an abrasive. Some people use chalk. I like to use that to kind of enhance the friction ability. So we have a combo with lubrication and a little bit of abrasiveness, and it gives it kind of a nice smooth moving peg, but it also has a little friction so that it grabs. The next step is to put the grooves in for the strings, and we just use a rat tail file for that. We can do a visual, or we can measure. The spacing here is usually 16 to 16.5 between the E and the G strings. So we just put enough pressure so that we have a little tiny divot. We don't want the strings to sit too deeply down into the nut. We want to put a little bit of graphite on each groove and kind of around the edge there. And this creates a little bit of lubrication for the strings, because all the strings are constructed kind of in the same way that we've got a core of the string, and they're wrapped with some sort of type of material, but we've got wraps going this way. And as the string is tightened and loosened, there's a lot of wear on that string. And a little bit of graphite, a little bit of lubrication helps, as well as not having the grooves too deep. So we've got the pegs ready to go and the nut ready to go. Next step we are going to talk about the soundpost. The soundpost is a little piece of spruce that is just wedged in there. It's not glued, it's a pressure fit. It will need to be adjusted occasionally. We just start out with a stick and then we use an old soundpost to put it in there, or we can use a tool like this to measure and just get a kind of an idea of what height the soundpost needs to be. So once we get an idea, we simply test it back and forth, trim it if need be, and we use this tool called the soundpost setter. Sometimes if I dip it in water, it will give a little bit, make this thing grab a little bit, because we're just pushing this into the side of the soundpost. I'm going to check it. I can look at it through the F holes. I can look at it through the N button hole. And I can check to see that I've got a good wood-to-wood connection there without any spaces. The soundpost serves as a very important structural piece as well as a sound transmitter from the bridge through the top, through the soundpost to the back. So if we have any gaps there on either end of the soundpost, then we lose some of our connectivity. So we make sure that we are nicely set there. So we've got the post in now, and when I get the bridge on, I'll show you where the post generally is placed to begin with. We've got our N button, which sometimes will need to be adjusted, usually oversized a little bit. We can take some off of the N button, and also take just a tiny bit of material out of the lower block. But we try to avoid taking a lot of material away from the existing structure. We'd rather modify what we're putting on and keep this as close to the original as we possibly can. So I've got my N button in, and that sound tells me that that's a good tight fit. I don't want to have to pound it in, but I want to have a real good fit. We need to take a look at the bridge. I've got an example of a bridge blank. We get these from the manufacturer, and that's kind of the starting point. It's what we use to create a specific bridge for each instrument, and it's very difficult to use a bridge from one instrument to the next because it's specifically fit in many ways. First, you see just the blank, and we've got the feet of the bridge just visually where the bridge is supposed to go, and we kind of use these nicks in the F holes as a guide to where the bridge goes. So we basically want this little inner nick on the right F hole here to bisect the foot of the bridge. So when we put the bridge here, if we were to draw a line from this little nick, that nick would hit that bridge foot right in the middle. We keep bringing the bridge back here as we shape those feet. So we remove material from the foot with a knife, and that's real important. The knife is very, very sharp. And we cut that so that we get, again, the perfect wood-to-wood contact. Just as I was mentioning before, the soundpost has to have that perfect contact, and so do the bridge feet. When the instrument is played, everything is in motion. There's a lot of vibrations going on here which create the sound. And whenever you have a gap in wood spacing, that's going to sort of detract that nice vibration that needs to go all the way to the back of the instrument. Once we fit the feet, then we need to figure out how high the bridge should be. As far as this will determine our string height. There are several ways of doing that. One way to do this after doing many, many, many instruments is just do a visual and eye. Put your eye down close to the nut. Some luthiers will just visually put their eye very close to the nut up here and visualize down and kind of have a good idea of how much material needs to be taken off. I'm going to now put on our set of strings. I like to go the outer two strings first. So we put the string through the string hole, bring it over, and then back toward the peg cup. And I'm going to go do the E string next. Same deal, through the string hole, swing back, and then back toward the peg cup. Now this is going to give me a nice idea of where my string height should be. I'm using this bridge jack, which is a nice little tool. I've done this for many years. Get some tension, tighten up the strings a little bit. And then this kind of gives me an idea of how high, how low I need to go on these strings. The bridge will follow the contour of the fingerboard, but we all know that with these different gauge strings, we have strings which are at different heights. The E string, which is the smallest string, has the most downward pressure. So this has got a lot of tension, and this string is a little closer to the fingerboard. That makes it easier to play. The widest string has much more flexibility and much less tension and downward pressure. So we need to give it a little bit of space to vibrate. It's going to vibrate a lot. So he's going to be a little bit higher. So this allows a player to really dig in and get a nice full sound without the string buzzing. So here I am using the bridge jack, and I'm just going to do some measurements here off the end of the fingerboard. There are some standard heights that are used, and all the way through sizes. I am going to adjust this full size. This will give me kind of an idea of where I can start on my bridge. What we do at that point is we take the knife, cut the crown of the bridge. You can put it on a sander. Either way, we need to remove that material. And we end up then with a bridge that has one side that is higher than the other, just as I talked about. I can put this on here and just give me see how close we are. There we are, right on with the heights. That looks good. So before we finish the bridge, once we get the height, then we will take a small bridge knife and do some additional carving away. When there's a lot of wood material, that tends to mute the sound. It's a principle that goes from the instrument to all the way to every part of the instrument. If the instrument is heavy in weight, that's going to lessen the vibration. Usually, if you were to compare a really, really nice, expensive violin to a really inexpensive violin, expensive violin is going to be much lighter in weight. It's going to be very light and allows for vibration of material, vibration of the top and the back. And that's called resonance. And we get much projection from that and a big fat sound from that. You can see these little areas here, the lungs, or the kidneys, some people call them. My original blank versus the one that's ready to go on the instrument. So I've cut material here and here, various areas. You can see the feet are not as thick on this one. So we've removed a lot of material, so this allows a much freer sound and much more projection. So at this point, I put my bridge on, put a little bit of tension down just so it doesn't move. And remember back when I was talking about placement, so I'm taking a look at this little notch here. I have an imaginary line coming across to the middle of the bridge foot, and that's about where it should be. Now I've got a little bit of tension here, Now I want to go back and take a look at my soundpost and make sure that I have placed that correctly. Because the placement of the soundpost is really important in relationship to the bridge foot. We want to have the bridge probably about at half of a diameter width of the post itself, that material behind the foot, 2 to 3 millimeters into the instrument. And that's weird. Kind of a good starting place where most instruments sound good at that point. So I'm just going to adjust that slightly, move my post in so it's a little closer to the bridge. And I don't want that post to be too tight. I want it just tight enough that it's not going to fall down when I shake it like this. Now I'm going to put the rest of the strings on here. So we've got our outer two. We'll put the A string on now. And we're going to put this guy on. With no existing strings holding the bridge up, we have to be very, very careful to slowly put tension on evenly. It's real easy to, like if your bridge falls out, say, you want to kind of come in here and put string tension very evenly across. If you put too much tension on one side, the bridge will want to shoot off this direction or vice versa. So we want to be very, very slow as we tune up also, because we don't want to bring the bridge forward and have it slap down, which could break the bridge and also create little marks from the string adjusters here. We've got the bridge where it needs to be. We tune it up. Always being careful to bring the bridge back, because you know, as we're tuning, the tension of the strings is pushing the bridge this way. Because we're tuning, we're pulling those strings, and the bridge will want to move forward. All right, we are up to pitch. At this point, we put on the chin rest. Let me find my little chin rest tool. There it is. We have a little chin rest wrench that helps us put this on. We want to go evenly with each barrel, not one all the way, but just kind of back and forth. And again, we don't want to make this too tight. We want that just tight enough to stay on. We don't want to have it clamped way down. We want to have it just tight enough to stay on. So that is pretty much it. We're set to go here. One thing that I neglected to mention regarding the finishing the bridge height here is we've got this really great little tool to get our spacing correct on the string spacing. This is a great little tool that will allow you to go down to 1/8, 10th size violin, all the way up to cello, to evenly space your strings. So that can be used, or just the plain old rat tail file. That's basically it.